Hi, today we're going to do number 3105, longest strictly increasing or strictly decreasing subarray. So we have an array of numbers and we want to return the longest. The output is a number that's the longest length of a subarray that's either increasing or decreasing, no equals. So here is increasing. For each number, it's increasing, and then from 1 to 4 is increasing, but then 4 to 3 is not, 3 to 2 is not, so that's the longest. And decreasing, this isn't decreasing, 4 to 3 is decreasing, 3 to 2 is decreasing, but it's not like 4, 3, 3, 2, because 3, 3, 2, 3s are equal to each other. And here, in this example, they're all the same value, so it's 1. So we can do a brute force way for this, where we do a nested loop. And inside of this nested loop, we'll have a current length count. And since each number starts off as 1, it's going to start off at 1, and we're going to need a max length count. And it's also going to start with 1. And we can also check here that the constraints, that it's going to be at least 1. So we know we can start the max length of 1. And then inside this nested loop, the trick here is that we can see if the pattern changes. So if we see the pattern goes from increasing to decreasing, we break out of the loop. If it goes the other way around, we break out of the loop. So check if next number changes from increasing to decreasing, vice versa, or equal. And we know if this happens, we break loop, and then we update max count, max length, I mean. And that's what we return, and we'll be able to solve this problem. The time complexity here is O of n squared, since we're doing a nested loop here. And then the space complexity is going to be O of 1, since we're using constant space. The space complexity is going to be O of 1, since we're using constant space. Or we can optimize this by doing a single pass. And here we can we do keep track of increasing and decreasing. And when we do this, update the counts as we iterate, or reset them to 1. And we can do it in a single pass by updating max length during each iteration, and then we'll get the answer with the max length. And by doing it this way, we'll have a time complexity of O of n, since we're doing one loop, and then the space complexity is going to be O of 1. And since the single pass has a better time complexity, we should go with that way, but I'll show you both. So here we have a max length, and it'll start off at 1, and that's what we're going to be returning. We're going to do a for loop, and also we need the other counts here that increasing length equals to 1, let decreasing length equal to 1, and then we do a for loop. And we can start off at 1, and we're going to can compare it with the previous value. So here, if nums I is greater than the previous one, we can do increasing length, increment it, and then reset decreasing length to 1. And then if it's less than, so it's decreasing, else if nums I is less than nums I minus 1, we can increment decreasing and reset increasing length. Else, if they're equal, we just set both of them to 1. And now we can update the max length that we're going to be returning. Increasing length, and then also with decreasing length, whichever one of these are the longest, and we can get our answer. Great. So we can solve this the brute force way. Well, we're still going to use the max length here, but we will define that within the loop. So for let I equals 0, I is less than nums dot length I plus plus. And here we get the current length, and it's going to start off at 1. And here, since we're starting at 0 here, we're not going to get the last one here value, so we can minus 1 here. Now we can do the second loop for let j equals I plus 1, j less than nums dot length j plus plus. There's no minus 1 here because this is it will be going to the last value. So here, and we can make a helper function here. So if it's not is valid extension, where we pass in nums I and j here, we break, else we update the current length, and then we update the max length. And now we do the helper function. So function is valid extension. So we're taking the nums, and the I will be the starting point. J is the current one. So it's not valid if the nums are equal to each other. The current is equal to the previous. So the current is always I plus 1, so we have a value to go backwards to. So if nums current is equal to the previous, turn false. And then here, to check if they are change direction, we first see if it's increasing or decreasing. So it is in the beginning. And we can do that by checking the start value, nums start, if that's less than the start plus 1. And then we compare that if it's currently increasing. And here we can get the nums of what we're doing currently if that's greater than the previous. And then we can return if they're both equal to each other. Because if they're both false, it'll come out to be true. Great, so that's how we solve this problem. We can brute force it by, for each one, we look at the nested value to see if that one is either increasing or decreasing and have a running count of it. And we can tell, just check if it changes from increasing to decreasing. If there's no change, it's valid. If there's no change from going up versus going down, if it's still going either up or down, it's valid, and we update the length and update the max length. Or we can just do it in one loop. By ideally, every time we do things one loop, we move things outside the loop, and just having a running counter of it, of the increasing one, the decreasing one, and get the max from after each loop. Reset the values to 1 if it changes. And that's all. Thank you.